Hey, I got a lot of questions about number 4 on homework 3. So let's take a look at this guy and see what we can do with it. For the functions given, f of x equals x squared plus 1 and g of x is 2 minus x, find both composite functions. Okay, so this would be a good review. And then the domain. The domain's always tricky. So let's work through this guy. Okay. First, I'm going to find f of g. First, I'm going to find f of g. So f of g, we have this notation, right? F, this little O, and it helps me always to rewrite that as just using kind of our normal notation. What does that mean? That means plug in g, the whole function g, into f. So I'll look at f, and everywhere I see an x, I just do a blank space. Okay, f of x is x squared plus 1. F of g is g squared plus 1. Okay, so I just plug in the whole function g. And when I square a square root, that goes away. And I'm just left with this. 2 plus 1 is 3. And there's my function. Okay, now let's talk about the domain of this thing. I think about two things when I do the domain. One, you have to consider the original function, because if you think about it, if you're going to plug a number into f of g, the first thing you do is plug it into g, square root of 2 minus x, and then you plug it in, and then you plug that output into f. For example, let's do f of g of 1. That means I plug in 1 into g, so that's f of g of 1, so that's 2 minus x, and x is 1. 2 minus 1 is 1, square root of 1 is 1, so I end up doing f of 1, and that is 1 squared plus 1, and I end up with 2. Okay, so if I f of g of 1 is 2, but if we talk about the domain, this is what you do first. You plug it into this square root function, right? And we got to be real careful with square root functions because there's domain issues. So, in other words, if I plugged in 5, that's not allowed, right? F of g of 5 does not exist because 2 minus 5 is negative 3, square root of negative 3 is an imaginary number. No good. Okay, so my point is when I find the domain of a composite function, I have to first consider just the input function on its own. Okay, so the g, I have to consider the domain of g, and the domain of g means that 2 minus x has to be non-negative, right? Because 2 minus x, what's under the radical, has to be a positive number. So if I solve this, let's see, there's two ways to do this. I would subtract 2, divide by negative 1, and we flip the sign around, right? So x is less than or equal to 2. That's the domain of just g now, just g, not f of g necessarily, but just g. All right, and that should make sense. Plug in numbers less than 2. 1's okay, 0's okay. Negative 5 would be okay, right? Because 2 minus negative 5 is positive 7. Square root of positive 7 is good. Okay, so this is the domain of g. And then the other thing, I consider two things. The domain of g, because that's the input function, domain of g, and then the domain of the result of my composite function. And I combine those two things. So the good news with this function is my composite function is a linear function. It doesn't have any domain issues. So the domain of the f of g is just restricted to the domain of the input function g. Okay, so that is everything less than or equal to 2. Let's see how we did. 3 minus x. Okay. Oh, we got to find g. Okay, so they're a little out of order. Well, I'm doing them in a different order. That's okay. So let's do the other way. G of f. All right. G of f equals, I like to rewrite it using this notation because that tells me everywhere in g, I'm going to plug in instead of x, I'm going to plug in f. Okay, so it's g is 2 minus x, square root. So I draw a blank space there and I plug in the entire function f, and then I simplify. So be careful, you got to run the negative. I see that mistake all the time. I'd see 2 minus x squared plus 1, but it's 2 minus x squared minus 1. 2 minus 1 is 1, and then I get that guy. Okay, so same thing. So this is a composite function, square root of 1 minus x squared. See if it likes my SQRT. Yeah, it accepts that. Okay, domain of f of g. We talked about that one. That was first. We still got to talk about the domain of g of f, but the domain of f of g, hopefully that made sense. It's less than or equal to 2, which is, interval notation would be negative infinity up to 2, and we're going to include that guy, so we need a bracket. Okay, one more to go, g of f. All right. So let's take a look at this guy. So the same idea. Remember, I want you to think about the domain of f first. Let's look at f. Polynomial function, no issues. Okay, so remember, consider the input function. So in this case, the input function is f, but that doesn't have any domain restrictions. The second thing to consider is our result, what we get for our composite function, and this guy's got some issues. It's a square root function, so what has to be true? Now these are tricky. 1 minus x squared has to be, same as before, here's the rule, greater than or equal to 0. Okay. So what I do with quadratic inequalities is I use the graph. The algebra here is a little, it's not terrible, but there's just some work to do. What I would do is graph this thing. If I graph this using a graphing calculator, 1 minus x squared looks like this. You did some transformations, so you know it's the x squared function, shifted upside down, moved up 1. Right, and the two intercepts should be here and here. So you want to know where is just what's under the radical, where is that positive, right? Just what's under the radical, where is that positive? So I want to know when 1 minus x squared is positive or 0, I should say non-negative. For what x values, right? And that's for the x values, it's positive on the graph when it's above the x-axis, right? So for what x values do I have shaded in here from -1 to 1? So my domain is anything from -1 to 1 should be okay, right? That is, if I plug in anything here, we go 1 minus, and another way to think about it is, well, what can you subtract from 1 and still be positive? It has to be less than 1, right? So or because you're squaring it, it could also be less than -1. Or I'm sorry, in between -1 and 1, because anything that goes bigger than 1 minus 2 squared, you got a problem, right? That would be a negative. Okay, there's another way to do these inequalities, and it's a little, I don't want to make this video is getting kind of long already, but if you factor this guy, difference of squares, then you could try and figure out what satisfies this inequality, right? In other words, what values for x would be okay. You could, what you do is you set it to 0 and solve for the zeros, which would be -1 and 1. And then you do like a little number line thing. Okay, that is when you got 3 sets here from -infinity to -1. If you look at the entire real number line, -1 to 1, and then 1 to infinity. Okay, and the reason for what I'm doing here is kind of related to the graph. I'm breaking up my quadratic, the entire real number line by the zeros, by the x-intercepts, because that's where it can change from positive to negative. And then what you do is you pick some test points. So I could say f of -2, a test point in this interval would be 0, and a test point in this interval would be 2, right? And if you plug it into this inequality, either the factored form or the non-factored form, if I plug in a 2, 1 minus 2 squared is negative. So he's out because it doesn't agree with that. 1 minus negative 2 squared. Negative 2 squared is positive 4, so that's negative. And then if I plug in 0, a test point, 1 minus 0 is 1, so that's positive, right? And that's the one we want because it agrees with this sign. That's kind of the long way to do quadratic inequalities. Okay, so I know that this is the set that I want, which matches this, and we do include the endpoints for here. Okay, so I know that's kind of a long explanation. This ended up being a tough problem. There's a lot of stuff going on here. One, the composite functions, and two, the domain of the composite functions. Again, for domain, consider both the input function domain and the result, right? And combine those two sets. In this case, for f of g, we only had to worry about g because f of g was fine. For g of f, we didn't have to worry about f because f was fine, no problems with f. And then we had to worry about the result, the entire function g of f. And then, to make it a little more complicated, we ended up with a quadratic inequality that we had to deal with. I like to look at the graph. Again, if you get a quadratic inequality, graph it and see for what x values is y positive, right? Is it above the x-axis? All right, well, I hope that helps. Sorry that video was so long, but let me know if you have any more questions.